When you send an email to a friend in Tokyo, it arrives on their phone in New York just a few milliseconds later. But beneath that speed is a massive communication problem. We have billions of devices out there, Windows laptops, iPhones, and servers, and they all speak entirely different digital languages. To solve this, we have to look back to the 1970s and a computer scientist named Vint Cerf. He and his team created a universal rulebook. This set of instructions meant that completely different types of early computing hardware could finally link up and share data across the globe, regardless of who manufactured them. That solution is called the TCP/IP model. You can think of it as a highly efficient, four-step digital postal system. That seamless experience is the result of a highly organized set of rules that ensures any device, anywhere, can communicate without confusion. Let's look inside this digital postal system. It starts at the top with step 1, the application layer. This is where programs like your web browser or email app actually format your data. It's the equivalent of sitting down and writing the letter you want to send. This layer uses specific formatting rules to ensure the receiving app can read the content, like making sure a website is written in a style a browser understands, or that an email follows a format your inbox can recognize. Once the letter is ready, we move to step 2, the transport layer. Massive files, like high-definition videos, are too heavy to ship all at once. There are two main ways to ship these pieces. The first is a reliable method called TCP. It takes your data, slices it into pieces called segments, numbers them in order, and requires a digital delivery receipt for every single one. If a piece gets lost in transit, it asks the sender to mail a replacement. The second shipping method is called UDP. This prioritizes pure speed over perfect reliability. It drops the tracking requirements and doesn't wait around for delivery receipts. This is what you need for live video streaming, where you'd rather have a tiny, unnoticeable glitch than a long buffering delay. The transport layer's true job is deciding how carefully data needs to be shipped, matching the delivery method perfectly to your application's unique needs. Now those pieces need an address. That happens at step 3, the internet layer. Its main goal is figuring out exactly where data is going and the best path there. Here, your segments are enclosed inside a digital envelope called a packet. The internet layer stamps the outside of this envelope with a from and a to coordinate, known as an IP address. You can think of this layer as the global sorting facility, calculating the most efficient route through millions of routers to reach the final destination. Finally, we reach the bottom step, the network access layer. This is the physical delivery truck that actually moves your data across hardware. Your packet is placed into a final shipping box called a frame, stamped with a hardware address unique to your device, called a MAC address. Then your computer converts that box into physical electrical signals, or Wi-Fi, to travel out. By isolating physical transmission to this bottom layer, software engineers build apps without worrying whether a user is on Wi-Fi, a cable, or cellular data. The postal system handles the translation automatically. This top-to-bottom process is encapsulation, the act of nesting data inside sequential digital envelopes. Reaching the other side, the receiving computer performs the exact reverse process, called decapsulation. It opens each envelope layer by layer until the original message is displayed. If you pick up a computer networking textbook, you might read about a different system called the OSI model, which uses 7 layers instead of 4. While that 7-layer model is a helpful theoretical teaching tool, TCP/IP became the standard because it was practical and streamlined. In 1982, the U.S. Department of Defense officially adopted this specific 4-layer system for its own networks, cementing its place in history. So the next time you tap send and watch your message vanish into the ether, remember that it is a highly organized 4-step digital postal system, working at the speed of light to connect you to the rest of the world.